ty bavili. Co jsem koukala, takže snad všechny, no, je, no.
Během fungování našeho projektu Akademie geoinformačních dovedností jsme si samozřejmě všímali i talentovaných dětí a například z letní školy geoinformatiky jsme potom vybrali 6 takových nejtalentovanějších dětí, z celkového počtu asi 4,5 tisíce a těm vlastně za odměnu, za tu jejich snahu jsme zprostředkovali o návštěvu přímo toho pracoviště ESRIN. Tak ESRIN to je reprezentativní pracoviště Evropské kosmické agentury, pracoviště zabývající se dálkovým průzkumem Země, si vybralo sídlo na východě od Říma a vybudovali tam v podstatě evropsky významné centrum pro rozvoj tohoto oboru.
Ahoj, já jsem Vojta, je mi 17 let a chodím do Prostějova na gymnázium.
Já jsem Ondra a chodím na gymnázium v Českých Budějovicích v Rostově ulici.
Já jsem Míša a chodím na gymnázium u Balvanu v Jablonci nad Nisou.
Já jsem Kuba, je mě 14 let a chodím na gymnázium v Boskovicích.
Já jsem Tomáš, je mi 18, chodím na stavárnu průmyslovku v Brně.
Já jsem Petr, je mi 17 a chodím na gymnázium v Klatovech.
V podstatě těm dětem se naskytne úplně unikátní možnost podívat se přímo do nitra, kde jak ten vývoj těch technologií, tak ten vývoj zpracování dat v podstatě běží a realizuje se.
Dobrý den, dobrý ráno. Welcome in ESA ESRIN. We try to technical explanation of what ESA does, Earth observation, satellites, remote sensing, but also with a field trip in the region, so that you can collect GPS data, correct the satellite images, and also enjoy the lake and maybe the kayak. Okay? All right. So let's start.
Pracoviště ESRIN Evropské kosmické agentury je významným partnerem Akademie geoinformačních dovedností. Je tomu tak proto, že kromě správy družic dálkového průzkumu Země se věnuje také osvětě a vzdělávání v těchto oborech. My zde můžeme přizvat lídra vzdělávacích aktivit dálkového průzkumu Země, doktora Francesca Sartiho. Why is education on remote sensing so important for you, for ESA?
It is very important for us to have education about Earth observation in general, about space science for kids, because this is the best way to communicate about our results and our mission in schools and for the young generation.
V oblasti průzkumu vesmíru. Soustředili jsme se na efektivní řešení, přičemž jsme vynaložili několikanásobně nižší prostředky než jiné státy, které se průzkumem vesmíru zabývají.
We will show also in a short video what we do here in ESRIN. ESRIN is this establishment. ESA is the European Space Agency, yeah? So that's why ESA. It's a Europejská kosmická agentura, something like that, yeah? Well, I think the pronunciation was terrible. Anyway, and ESRIN means European Space and then Research Institute. Okay, so ESA is not doing only Earth observation. We are doing many different things related to space science and space technology. We have also human space flight, so we send astronauts in space. We have been designing over 70 different satellites and many type of launchers also. We develop rocket missiles to bring satellite into space. We have also telecommunication and navigation. Navigation is like GPS, you know what GPS are. And Europe has a program, ESA also has a program to improve geostationary orbit. You see it's very far away from the Earth.
V českém prostředí vzdělávacích programů je taková nevýhoda, že grantové projekty jsou většinou krátkodobé, takže máme prostředky, já nevím, na 1, 2, 3 roky aktivit. A potom většinou tyto aktivity skončí. To je vlastně nevýhoda pro nějaké dlouhodobější vize nebo plánování nějakých dlouhodobějších aktivit. A právě díky spolupráci s ESA, s pracovištěm ESRIN, jsme schopni naplnit nějakou dlouhodobější vizi.
So this is a model of ENVISAT. ENVISAT is the biggest satellite that we have ever built and sent into space. It has been operating for 10 years, and it's the most complex satellite for Earth observation that ESA ever did, because it consists of 10 different instruments, not only one, taking simultaneous observation of the Earth. EMISAT flies on an orbit which is inclined by 98 degrees with respect to the equatorial plane, so it is almost polar, and this allows to have a polar revisit almost in every orbit. And in this way, the synthetic aperture radar is illuminating the Earth, and when you put together many acquisitions of the antenna along the orbit, you can imagine that the antenna is like a huge antenna, because you are putting together all these measurements taken along the orbit. Because otherwise, in fact, the resolution on the ground, so how accurate the radar is, would depend on the length of the antenna. This is limited, of course, physically. You cannot put an antenna which is some kilometers long. The next satellite is Goce. We call it Goce using the Italian pronunciation, but somebody pronounced it Gos. And this is a very unique satellite because it doesn't take images of the Earth like the other instruments, but it measures the gravity field of the Earth.
Takže jsme někde tady, ne?
Tady je ta vega, ne?
So, if now we went out from this building, from there, we'll go to that corner, and that corner corresponds to this point. And there, each of you takes the GPS coordinates and writes down on the paper the coordinates that you see for this point. If during the trip you get very hungry, we can also interrupt, go for lunch, and then continue after lunch. Okay. We are not obliged to take all the points before lunch. This is not part of the GPS point collection. I wanted to show it to you. This is a huge antenna. And this satellite is a sort of bridge, it's called Data Relay Satellite, DRS, between polar satellites and us. So the polar satellite was EMBISAT, so it collected a lot of data all the time about the Earth. Yeah, this is the last years. You can see how many objects have been discovered in the last years. Really, the main belt is full of objects. We know more than 300,000 objects between Mars and Jupiter, and about 10,000 which are orbiting in the region, which are entering the inner planetary region, so which can pass close to the Earth. What we are doing here is to face the problem of the asteroid hazard and contributing to the worldwide efforts in solving this problem. The problem is the distance and the fact that nothing can travel faster than light, at least for what our knowledge. And so this means that even the closer star means years and years of traveling. Well, the Chelyabinsk event in Russia was really a big surprise, because usually you get false alarms, people pretending that something has happened, and this time was true, and it was a fantastic event also because they used to have the small cameras on their cars in Russia, and so we had incredible documents of what actually happens when a small asteroid is falling. The worst case is the asteroid is so big that if it crashes, there is a mass extinction, all these scenarios which are in the movies. But again, if this happens, then we can send spacecraft and try to deflect it. It depends on how much time we know it in advance. 99.9% of the time is to say, don't worry, it's not a problem, this asteroid. It will pass away from the Earth.
Anything is falling down today?
Okay, maybe I have a question. A good question, because we didn't know that the Chelyabinsk event was happening. So we have made major progresses. We know a lot of asteroids, but it takes still more time to know them all.
So there are still a large fraction of small asteroids that we do not know where they are.
Do you have a telescope here in ESA or which?
ESA has a telescope in the Canary Islands.
Yeah.
Now telescopes, you cannot put a telescope
Yeah,
there
I know.
because it's too much language. I would really like that someone is visiting us sooner or later, but the odds are against it.
Check the book. Now we are in the village of Castel Gandolfo, and this is the Pope Palace. We are on the front. What you see here is the gardens. They have these stripes, but we cannot enter the garden because the Pope told me that today he's busy. So we are on the square. And now we look for the coordinates with GPS. So this second building to the right.
Co teď děláme teda?
Takže teď jsme na bodu číslo 5. A zapíšu šířku.
A proč tu budeš zapisovat tu zeměpisnou šířku a délku?
Aby jsme vlastně věděli svoji polohu.
A k čemu ji pak budeme používat? A proč tu budeš zapisovat tu zeměpisnou šířku?
Budeme to dělat pomocí družicových snímků.
No, co s tím snímkem budeme dělat? Proč potřebujeme ty souřadnice, aby jsme ho ortorektifikovali?
Získáváme souřadnice bodu, který potom použijeme na zpracování družicových snímků v Leoworksu a určíme tím správnou polohu.
Okay. No, okay. Co ty děláš? Takže sbírám v terénu GPS body a jejich souřadnice, abych s pomocí nich mohl v programu Leoworks přidat družicovému snímku souřadnice.
Jo, dvakrát.
Tutto na full screen. Tutto na full screen.
Takže nacházíme se tady v ESRINu v učebně, kde provádíme takové praktické cvičení. My jsme vlastně se pokoušeli spojit vlastně družicové snímky na ortorektifikovat je, to znamená vlastně umístit je do mapy, předět nějaké souřadnice, a to na základě GPS bodů, které jsme včera nazbírali. To znamená, měli jsme vlastně ty GPS body využít k tomu, aby jsme umístili ten snímek správně do mapy. Ale úplně se nám to nepovedlo, protože ten program zrovna nám trošku tady zastávkoval. Poté, co jsme tam ty body zadali, tak vlastně neproběhlo to spojení. On se nějak tam zasekl a vlastně spadl během té transformace. Zkoušeli jsme to v programu Leoworks, což je vlastně program, který je vyvinutý speciálně pro středoškolské vzdělávání. Takže to ta ESA vyvíjí vyloženě pro školy a ani se nepočítá s tím, že by se v tom opravdu dělaly nějaké vědecké postupy, protože to by zase bylo pro středoškoláky moc složitý.
Is a mathematical function. It's a variation of any physical variable versus a direction. So, Gaussian measures the variation of gravity versus x, y, z, etc. After 60 days, everything will be completely.
And what you're seeing here on my right is the core instrument of the Gaussian mission. It's called a gradiometer, a gravity gradiometer in fact, because this is an instrument that measures tiny variations in the Earth gravity field from position to position. So you can think of this instrument as the balance or the scale in your bathroom. So you put yourself on a scale and you measure your weight and you write down the value, and then basically you move yourself by half a meter, which is the distance between these sensors, and you measure yourself again. And the difference of those two measurements, so you measure your weight here and here, this is essentially what this instrument is measuring in space, and it does that every second and has been doing so for about 4.5 years. And why do we do this? We do this because the Earth's gravity field is a fundamental property of the planet. It reflects the distribution of masses inside of the planet, and it also determines what is up and what is down. GOCHA was launched in 2009, has been working remarkably well. It produces all of the science that was expected, and unfortunately the mission is about to finish because we will run out of fuel, and in a few weeks the spacecraft will re-enter into the atmosphere of the Earth.
Please. Nice booster. Okay, good. Again, someone.
Thank you.
And let's see why you got this passport and this prize. Ah, yes, because you were the best actor in the video interviews during these ESRIN days yesterday.
Thank you very much.
Thanks, Misha. Congratulations. Let's see what you did special. But I think I remember. Yes, you are the best sound engineers on board kayaks in the lake of Castel Gandolfo. So, congratulations. Again, one of the most brilliant students of the Czech Republic that we know already. He also the one who asked the largest number of questions, and we are very grateful to him for that, to make the presentation alive. So you also get some present for us, and this is also a key ring with an astronaut. Bravo. Thank you. Thank you. So who's the next?
Tak je to jezero Castel di Gandolfo a je to jezero, který je v kráteru sopky. Takže to jezero je v podstatě zaplněný sopečný kráter vodou a uprostřed je hluboký jak 200 metrů.